The rectangular milk carton has a square base which holds 1 liter of milk. It has a specially designed fold-in top. The area of the cardboard used for the top is 3 times the area of the base. So question 11.1 says, show that the total surface area of the carton is given by. So a of x is equal to 4x squared plus 4,000 over x. So first thing I want to do is I want to work out the surface area. So I'm going to do 11.1. So let's do the surface area. I'm going to work out the area of the bottom. So area of the bottom, that's going to equal, so if I had to just draw out the bottom here, the area of this is going to be x times x, which is x squared. Now, we don't need to worry about the top because they tell us that the top is 3 times the area of the base. So the area of the top is going to equal 3 times the area of the base. Then we can work out the area of the sides. So the area of the side pieces. So the side has a height of h and a breadth of x. So that's going to be h times x. And I have 4 of these. So it's going to be 4hx. Now we need to take a look at the volume. They've told us that the volume of this container is 1 liter. So 1 liter is equal to 1,000 centimeters cubed. So the volume of this container is going to be length times breadth times height. So 1,000 is equal to x times the height. So 1,000 is equal to x squared multiplied by the height. Now we can rearrange this formula in terms and solve in terms of h. So h is equal to 1,000 over x squared. I can then take this and substitute it here. So the total area is going to equal x squared plus 3x squared plus 4, and then h is 1,000 over x squared, and then multiplied by x. So this is going to give me 4x squared. Then the x will cancel there, and I'm going to have 4,000 over x. And that's the same answer as what they wanted. Now 11.2. Determine the dimensions of the carton so that the minimum amount of cardboard is used. So we want to do optimization here. We want to work out the minimum. So the steps to do optimization are as follows. First, we need to set up the equation such that we have no fractions. So a of x, so the area is going to equal 4x squared. So a of x is going to equal 4x squared plus 4,000 times x to the power minus 1. The reason why we want to do this is because when you are optimizing, you need to take the derivative, and it's not easy to take a derivative when you have a denominator. So the derivative of this, so a prime x is going to equal 8x minus 4,000 x to the power minus 2. Now we want to minimize this, so we'll set the derivative equal to 0. So 0 is equal to 8x minus 4,000. And then here you can just bring it back to the denominator just to make it a bit easier. And now you can solve for x. So x is going to equal 7.94 centimeters. And we already have an expression for h. So the height is going to equal 1,000 divided by 7.94 squared, which is 15.86 centimeters.